Children, in our previous video, we have gone through similarity and we have discussed this basic proportionality theorem and its converse. So, I think till now you have understood what is similarity, what is congruency. In today's lecture, children, we are starting with few questions related to this similarity or basic proportionality theorem. In your NCERT book, we have exercise number 6.2 we are going to address in this lecture. So, I am taking few problems of NCERT so that you can easily understand how to apply basic proportionality theorem to various problems. So, our first question I am taking here from the NCERT is question number 3rd. Now, in question number 3rd, he is telling us that you have a figure here. In this figure, he is telling LM is parallel to CB. So, this is given to you, children. LM is parallel to CD. This part is given. Okay. This part is given that LM is parallel to CB. Second part is also given, that is LN is parallel to CD. So, this is also given, LN is parallel to CD. Second part, right? This is also given. So, you can understand these two things are given to us. We have to prove this part. We have to prove AM over AB, AN over AD. Okay. Let us start with the solution, children. The solution to this problem is, okay, see, first of all, we will take here the triangle ABC. So, I am taking the triangle, children, ABC. Okay, understood? Which triangle I am taking? ABC. Now, see, in this triangle, it is given that LM is parallel to CB. You understand? LM is parallel to CB is given to you. Now, if you apply basic proportionality theorem, then you get here AM over MB. We get here AM over MB is equal to AL over LC is equal to AL over LC. That is number 1. Remember, children, you have to write the reason here. From where you have written this BPT, basic proportionality theorem. I have taken this result because of BPT, basic proportionality theorem. Examiner clearly watches what reason you are giving here. Only then you will get the marks. Okay, children. Now, I am coming to the second triangle here. I have a second triangle, this one, ADC. So, I am taking here the triangle ADC, children. Now, in ADC triangle, you can see here we have given LN is parallel to CD. LN is parallel to CD. Okay, children? LN is parallel to CD. This is given. Again, we apply the BPT, that is AN over ND. AN over ND is equal to AL over LC. Is equal to AL over LC. This is number 2. Again, I have taken this result because of basic proportionality theorem. I have written this result because of basic proportionality theorem. Understood, children? Okay. Now, see, here you get AL over LC. AL. So, these two things are common, children. So, you can say here from 1 and 2. If you compare these two results, children, we get here AM over MB is equal to AN over ND. Okay. But children, we have a problem here. The result is not this one. Okay. You have to prove AM over AB. But here we are getting a different result. So, what to do? to get this result, you just take the reciprocal of it. So what is the reciprocal of it? MB over AM is equal to ND over AN. In order to prove this result, I have taken the reciprocal of this. Now add 1 both sides. Add 1 both sides. We can do, children, that. Okay. So we are writing here MB over AM plus 1 is equal to ND over AN plus 1. If you simplify it further, children, you get here AM, here you get MB plus AM, and here if you take AN, here you get ND plus AN. Now children, this result I have taken LCM. If you multiply, you get AM here. Now you just carefully watch here. MB plus AM is nothing but AB. So from here we get AB right over AM is equal to ND plus AN. ND plus AN is nothing, AD. We get here AD over AN. Okay, children. So you can take the reciprocal of this. Take the reciprocal of this. You get AM over AB is equal to AN over AD. So this is the result we have to prove. So this is very simple, how to use BPT in question number 3rd. Okay, children, have you understood it? Okay. So children, let us start with your next problem, that is question number 4. Here you have a figure here, and in this figure it is given that DE is parallel to AC. Now where is DE, children? This is DE. This is given parallel to AC. This part is given. You can see here this part is given, and DF. So this DF is parallel to AE. This part is also given. Okay. So let us start with, we have to prove this part. We have to prove BF over FE is equal to BE over EC. This is again a very easy question, children. You have to do one thing here. First of all, you take this triangle. Which triangle you will take initially? DE. DE is parallel to AC. So I am taking the bigger triangle. Here I am taking the triangle BAC. Now see, in this bigger triangle, what is given to you? Here you have given DE. DE is parallel to AC. This is given. Okay, this is given here. Okay, DE is parallel to AC. This is given. Now we can apply BPT here. We get here BD over DA. We get BD over DA is equal to BE over EC, right? We get BE over EC. Let it be number 1, and we get this result from BPT, basic proportionality theorem. We have taken this result. Okay, understood, children? Now you have DF is parallel to AC. Now for this, for the second case, you take the triangle. You take the triangle. Which triangle you can take? BEA. So I am taking the triangle BEA. Now see, in this triangle BEA, what is given to you here? DF is parallel to AE. So you can see easily here DF is parallel to AE. From where again, if you apply BPT, you get BD over DA is equal to BF over FE. BF over FE. This is number 2 result. Again we have taken this result, children, from BPT, right? So again here you see this is parallel to this, so this upon this equals this upon this. So this second result again we have got from BPT. Now children, if you clearly observe these two results, first and second, you find here BD over DA, here also BD over DA. So you can say here from, it is clear from 1 and 2. What you get? You get BE over EC is equal to BF over FE. See, this is the result. This is the result. Here you get BF over FE is equal to BE. You can write it like this also, no problem. You can write it like this, is equal to BE over EC. So children, this is your question number 4. Quite easy. Have you understood? Only we will we can directly apply these results of BPT and we get the answer. Okay. So children, let us start with our next question, question number 5, right? Here in this question, you have a figure given. In this figure, he is telling that DE is parallel to OQ. Just clearly watch children, DE is parallel to OQ. This is given. DF is parallel to OR. The second result, DF is parallel to OR. This part we have to prove. This part we have to prove. Let us start with this result. Again, a very easy question, children. See, first of all, you take the triangle PQO. So I am taking here the triangle PQO. Okay, children. Now, if you apply BPT, you see what is given here. You have given here DE is parallel to OQ. Now this is parallel to this. So this upon this is equal to this upon this. So you get here PE upon EQ is equal to PD upon DO. Let it be number 1, children, right? Now you take the another. So from where you get this result? From you get this result from BPT. You have to mention it here, quite important. Okay, now I'm taking here which triangle? I'm taking the triangle POR. So here is your triangle, children, POR. Now you see in this triangle POR, DF is parallel to OR. DF is parallel to OR. DF is parallel to OR. So again, if you apply BPT, you get PD over DO is equal to PF over FR. Again, this is number 2 and this is because of BPT. I have written this result because of basic proportionality theorem. I am again telling you, you have to mention it. Otherwise, examiner will not give you the marks. You have to write the reason. Right. This is, so we have two results. Now in these two results, children, if you check, this is PD over DU. This is, so they are equal. So you can say here from 1 and 2, we get what we get? We get PE over EQ is equal to PF over FR. We get this result, you see, directly. Now if you check it, you see, now you get PE over EQ is equal to PF over FR. Now if you, what does it mean? It means EF is parallel to QR. Now from where I have written this result, this is converse BPT. This is due to the second theorem, that is converse of basic proportionality theorem. We get EF is parallel to QR. So this is the result we have to prove in this question. Okay, children, this is your question number 5. So let us start with now question number 6, children. You have given here a figure. In this figure, what is given? A, B, C are the points A, B, C are the points on, A is a point on OP, B is a point on OQ, and C is a point on OR, such that this is also given AB is parallel to AB, AB is parallel to PQ, this is given, and AC is parallel to AC, AC is parallel to PR, this is given, AC is parallel to PR. So we have to prove here AC is parallel to, we have to prove that BC is parallel to QR. So this part we have to prove. So let us start with, children. Again, this is very easy question. So I am taking here, now I am taking here, first of all I am taking the triangle OPQ. So this is the triangle OPQ. Now you see in this triangle OPQ, AB is parallel to PQ, right? So if AB is parallel to PQ, what does it mean? It means OA over AP is equal to OB over BQ, OB over BQ. So let it be number 1, children. So I have taken it number 1. Okay. Now I am taking now this triangle. I am taking the triangle OPR. Now in this triangle OPR, you see here we have OA over AP is equal to OC over CR. This part again we have taken because of BPT. Here again, this is again because of BPT. We have taken this result because of basic proportionality theorem. Let it be number 2, children. If you clearly observe these two results, you get OA over AP here, you get OA over AP here also. So you can say here from 1 and 2 we get the result OB over BQ, OB over BQ is equal to OC over CR. Okay, if these two things are equal, then these two results will also be equal. And now children, now we have proved one thing, this upon this is equal to this upon this. So you now take the triangle OQR. So if you take the triangle OQR, you get here OB over BQ. This we have just proved OC over CR. Okay, children. So we will apply here converse. What does it mean? BC is parallel to QR. I have done nothing. This is because of converse BPT. Because of converse of BPT. So again, so we have proved the third result, means this line is also parallel to this line. So I hope you have understood this. Okay, children. Okay, children, let us start with your next question. Question number 7. Using BPT, prove that line is drawn through the midpoint of one side of a triangle parallel to another side, bisect the third side. This is a very simple question, children. Look what is given here. You have a triangle here like this. You have a triangle like this. This is your triangle ABC. Okay. Now what is given here? What is given here? You have a line DE. This line is parallel, and also this is equal to this. See, this is given through the midpoint of one side. So what is given here? You have given in triangle ABC, AD is equal to DB and DE is parallel to BC. Okay, children. So what we have to prove? We have to prove that AE is equal to EC. Okay children, understand it. Then to another side, bisect the third side. So it is bisecting third side means AE is equal to EC. So children, you simply apply BPT. See here, this in triangle ABC, DE is parallel to BC. What does it mean? It means AD over DB is equal to AE over EC. But AD and DB are equal, so they cancel out children. And from where you get EC is equal to AE. This is the only thing you have to prove. Therefore, you can say E bisect AC. So very simple question. Understood. Here children, in question number 9, you have given a trapezium. Many of you children know what is a trapezium. In a trapezium, a pair of opposite sides is parallel. So here I am drawing a trapezium like this, and children, you can call it as A, B, C, D, and these are its diagonals children, like this. O is the point where they are intersecting. So what is given here? You have ABCD is a trapezium. So this is given with AB parallel to DC. This is given. Okay children. So what we have to prove? This part we have to prove. Okay. So you do some construction here. I am doing a construction here like this. OE. Let OE is parallel to AB and CD. Obviously, if this line OE is parallel to AB, automatically it will be parallel to DC. You can understand it. CD or DC, one and the same thing. So if this is parallel to this, it is also parallel to this. So let us start with, initially you take the triangle DAB. Now in this triangle DAB, you have DE over EA is equal to DO over OB. This is nothing, BPT I have applied children directly. Similarly, here you take the same triangle. I am taking the triangle here ADC. In this triangle, this EO is parallel to DC. From here you get AE over ED is equal to AO over OC. Again, we have used here BPT. Okay. Now children, if you just watch these two results, I mean you take the reciprocal of this, you just take the reciprocal of this result. From here you get ED over AE is equal to OC over OA. Now you watch this and this, they are equal. So what does it mean? It means this result, I am writing the result here actually. See, so from here you get DO over OB is equal to OC over OA. Now you check, you have to prove this result, right? You have to prove this result. So you take OA to that side over OB is equal to OC over OD. You just check this result as well as this, they are equal. So with this children, I have taken few problems of basic proportionality theorem and its converse. This is your exercise number 6.2 ncert. Children, mathematics is a very easy subject. Also, it is one of the beautiful subject. So try to learn it in the easiest way. So if you have benefited or understood this topic, share this video with other children also, so that they can also get benefited. This is my free effort to all of you children during Corona period, so that I can help you to study better by staying at home. Further, if you think that you want to give some comments in the comment box, you should give your comments so that I can help you in the best possible way. And if you think that this video is appropriate, press this like button and subscribe my channel, so that you can learn mathematics in the best possible way. Okay children, thank you.